I personally think this is the toughest question in the paper. To try and visualize this single plane in 3 dimensions is not easy. We're told that the side lengths are 2. We'll come back to that in a minute. And then we're also told that a single plane cut goes through Y, T, V, and W. Now you might think just join these up and then find the area of the rectangle that is created. But actually, that is not the plane that goes through the whole shape. Now the edges will be Y, T, and W, V. And actually, I'm going to draw straight lines here. And if I connect Y and W together, then that is not at the very edge of the cube. W is and Y is, but we could actually extend it even further. And we can in fact extend it this way. We'll end up at the midpoint of this vertical line here. Actually, that's where the plane ends up going to. And then if we look at T and V, again, V is at the edge of the cube and T is, but we can extend it the other way. And again, this is without proof, but you can actually take it to the midpoint of this vertical line here. We actually create a regular hexagon. It doesn't look like a regular hexagon, but that's because we're working in 3D here. You can see that every edge is actually the midpoint of an edge to another midpoint. So they are all going to be the same length. Now here's using GeoGebra to try and visualize it a little bit better. So you can see the cube and you can now see a little bit better the plane that's taken place. There we go. That is our plane. So when we move it around like this, you can see it does become this hexagon shown on the right. So that's probably where you might, a lot of people slipped up here, would have calculated the rectangle and not realized that actually it's this hexagon. Once you've realized it's a hexagon, actually we're off and running. And I'm going to go through it in a couple of different ways. So first thing to say is that this here is a right angle triangle. That's a right angle, and this is length 1 and 1. So actually the hexagon has sides √2. Okay, and here's the quick way how you can find the area. A hexagon is made up of 6 equilateral triangles. Because the angles in the hexagon are irregular hexagon are 120, each of these is 60. What did it mean that one is 60? So I can just find the area of one triangle using a half AB sine C, half √2 squared times sine 60, and then I can times through by 6. So the half and the √2 squared actually cancel, and then sine 60 is equal to √3 over 2, giving us a final answer of 3 √3. Of course, you don't need a half AB sine C. You could split your equilateral triangle up. So we're going to have √2, and then this here would be a half of √2, so 1 over √2. Then we can do Pythagoras to find the height, which would be the hypotenuse squared minus the base squared, then square rooted, which is the square root of 3 over 4, or √3 over 2. Here's one other way to get the area. It's got to be said this way is more complicated. So we could draw a rectangle that we had at the beginning. And if you had have accidentally thought the plane was just this, then it would also tell you what answer you would have got. And I think it's not on the list, so it means that you know that you've made a mistake and that there was more to it. That's the nice thing about this question. I didn't put that answer in to trick you. So we know that this is √2, And then to get the height of the hex, well, not the height, yeah, the height of the hexagon, sorry, it's going to be TV. And I can use 3D Pythagoras. I'm going down by 2, and I'm going to the right by 1 and back by 1. So it's 2 squared plus 1 squared plus 1 squared square rooted. That's, you can draw the triangle if you want. Have it going sort of down to here and then to here. Maybe that makes it a little bit clearer. And then we have to work out this length, which is √2, or you get it by doing 1 squared plus 1 squared square rooted there. But anyway, this is what we're going to get, which is √6. Which means the area of the rectangle is going to be √12 or 2√3. Okay, so that's what you would have got if you'd gone with the whole thing. Maybe you might have then thought, hey, it's going to be, maybe I've missed something. Maybe it's 3√3, because you know that 2√3 is kind of in there. But anyway, now let's deal with the triangles. So for this, if I could find out here to here, then I'd be sorted. And that is going to be, well, I haven't labeled this point, but this point to this point. Now, I can actually draw a right angled triangle going like that. It's going to be 2 squared plus 2 squared square rooted. It's going to be √8. So that is the diagonal lengths in the hexagon. Which is actually 2√2. And if I then minus √2, I'm going to get √2. And if I divide by 2, then this is 1/√2. So then each triangle is going to be a half times the base, which is √6, times the height, 1/√2. And then I'm going to times by 2 because there's 2 of them. That's both of these triangles. Like I said, this is more complicated. A 2.5 cancel. I'm just going to get √3. Okay, that's for the 2 triangles. And I add up the √3 and the 2√3, which gets me 3√3 as well.